So to summarize, if you take a look at a function, the first derivative will tell you a bunch of things. The second derivative just tells you concavity and points of inflection. So the first derivative tells you where it's increasing, where it's decreasing. So from, let's say, from here, the first derivative is positive here. The first derivative, that's the slope of the tangent line, would be 0 at this point, which would be a local max here in this case, because it's negative afterwards, you see? So this is first derivative. And then it's going to be 0 over here again, and positive on the other side. So that's first derivative. So first derivative will tell you where it's increasing, that's where it's positive. It'll tell you where there's a local max or min, and that's when it changes from positive to 0 to negative. Oh, sorry, that's a local max. And a local min where it changes from negative 0 to positive. Okay? So increasing here, right? It's the derivative is 0 here. The function is decreasing because the derivative is negative, and this is your local max.
Okay, wait. For the second derivative test, find first derivative, find the critical numbers of first derivative, and then find second derivative, but you don't need to simplify.
Let me tell you about the second derivative test. Let me just finish my story. I'm going to tell you about the second derivative now, okay? And I'll show you why the second derivative test is a thing. So the second derivative, if I overlay it on the same graph, let's get rid of some of this. Okay. So the second derivative is going to show, and I'll do it in blue here. Actually, I'll do it in blue. Second derivative. So it's tough to tell right here because I didn't draw that very well, but let's say this is concave. This is concave down here. Oops, this is getting worse. Okay, so it's concave down. So this second derivative is negative here. Okay, it's negative here because it's still concave down. Even through this local max, it's still concave down. You see, this is still part of a downward parabola. It's only about here that it changes. So there's no concavity there. And then here, it's concave up. You see that? So the second derivative is different than the first derivative, and it tells you about the concavity. So here, it's concave down. Like this would be kind of like the parabola that it's a part of. See, always concave down. And then over here, the rest of the section is part of this parabola that's concave up.
And then the 0 for the second derivative, that's a critical number?
No, the 0 for the second derivative is not called the critical number. No, that's just that's a point of inflection. So these are critical numbers right here. That's critical number 1. This is critical number 2. And this one here is point of inflection. See, that's the x value for point of inflection. Well, this is the x value. So if you let the second derivative equal 0 and solve for x, that gives you the x value. And these are all x values. X value here, x value here, x value here. You would have to go back to the original y and plug that x value in to get the actual y value that completes that point. The point for the local max, for the point of inflection, and for the local min. Now, second derivative test. You asked about second derivative test. So watch this. I'm going to clean this up a little bit, but watch carefully. If knowing that there's a critical number here, if you didn't know about the sign of the tangent slopes there, if you didn't know about that, you could just use the second derivative. So for this critical number, it falls in this region right here. And because this graph is concave down where this critical number is, that means that the graph, this has to be a local maximum. So second derivative, if you put the critical number into the second derivative and evaluate the number, if it turns out to be a negative value, that means it's concave down, that means you have a local max. So the second derivative test is plugging critical numbers into the second derivative. If it's negative, you have a local max there. And look at this one. If the value is positive in this little area where the second critical number is, if it's positive, that means it's concave up, and then you have a local min. So you don't have to do the first derivative sort of sign analysis and the second derivative test. They find the same thing. You could do either or. That make sense?
Yeah.
Okay. Have a good afternoon.